So again, welcome to everyone. Today we will talk about carbon sequestration. So this webinar is organized by the Bovine project, and Bovine is Beef Innovation Network Europe, and it's a European thematic network project. Within this project, we collect the needs from the beef farmers, and based on these needs, we select priority topics where we work on the next year. And these selected topics are related to different thematic areas: socioeconomic resilience, animal health and welfare, environmental sustainability, and production efficiency and meat quality. Related to the different topics, we collect research innovations and good practices, and all information gathered is shared through different platforms. Our main platform is the Bovine Knowledge Hub, and you can see a QR code which leads you directly to the hub. And this hub, here we collect all information from the Bovine project. So everything related to these innovations, good practices, presentations, other articles, you can all find this information on the hub. And next to the hub, we also organize demonstrations, webinars, and other events, but we also publish articles in, for example, local magazines. I'm the leader of the work package on environmental sustainability, and this webinar is linked to the priority topic of carbon sequestration, which was covered last year. So today I will start with a short introduction on carbon sequestration. Then Paul Pardon from ILVO will talk about agroforestry and carbon farming. Olivia Barantes from Unisar will explain more about holistic management. Hélène Chambaud from IDEL will talk about the tools, the Cap de Serre tool and the Car Soleil. And Enyo Fak from ILVO will talk about reward schemes for carbon sequestration. If you have a question, you can ask your questions in the question box that you normally can see on the right of your screen. And at the end of the webinar, we will go over the questions and we will answer them. So as you all know, the climate is changing fast, and factories, transport, and agriculture are all releasing carbon dioxide into the atmosphere. And the more carbon dioxide we have in the atmosphere, the warmer the planet will get. So it is necessary for us to lower these emissions on the one hand, but we can also try to capture the carbon dioxide and look for solutions there. And in this, plants are able to collect this carbon dioxide by photosynthesis, and they are able to store the carbon in the soil, but also in the leaves, the stems, and the roots of the plant itself. And this process is called carbon sequestration, and it contributes to mitigate the global warming potential of carbon dioxide. So then if we look to the global levels of the greenhouse gas emissions by sector, we can see that agriculture and forestry are a big contributor to these greenhouse gas emissions, together with the electricity and heat production and also the industry. And then if you look more specifically to agriculture, then we see that the feed production and the feed processing is a big part of this, but also the enteric fermentation. And this is also translated if we look at the carbon dioxide equivalent per kilogram of protein, then these numbers are much higher if you look at beef than if you compare it with other types of protein like pork and poultry. So in beef, we are emitting 3 times more carbon dioxide equivalents per kilogram of protein compared to the other types of meat. Then here you can see the global greenhouse gas emissions per region. And first of all, what everyone will see is, of course, that Europe, if you compare it to, for example, Asia, is not the biggest emitter of all. But you also need to watch out if we lower our productions, that there will be a shift of production to these areas and make the emissions even worse. And it's also important for us to transfer our knowledge to the other regions and keep on improving our numbers, because we might have the lowest numbers if you compare it to the other regions, but the emissions that we have in Europe are also still too high and a big part of the global emissions. So what is the role of agriculture in global warming? So as you could see before, and also in a lot of other communications, we see that agriculture is a big part in this climate change. However, agriculture also has a great potential in mitigating global warming, and this can be done, for example, via carbon farming. And within carbon farming, this can be, for example, agroforestry, which Paul will talk about a little bit more. But we can also work with catch crops, cover crops, conservation tillage, which is also already done by many farmers. We can also look at more targeted conversion of cropland and especially permanent grassland. But in the next slide, I will show you the potential of this permanent grasslands. And also restoration of peatland and wetlands, and afforestation and reforestation will all help in carbon farming and improve this carbon sequestration. So here in this picture, you can see the potential of the different systems. You can see that underneath a forest in the soil, the potential of carbon sequestration is 80 tons of carbon per hectares. And it has the same potential underneath grassland, but of course in permanent grasslands. So it has, in agriculture, we have also great potential of sequestering this carbon under this permanent grassland. So this is really important, because if you compare it then with arable land, you can see that the potential is much lower than this permanent grassland. So sequestering more carbon into the soil is not only important for mitigating global warming, but it can also improve the production on the farm, because higher levels of carbon in the soil, they can have a beneficial effect on your soil fertility, the resilience of the plants, biodiversity, prevention of erosion, preservation of agricultural capital and production capacity. But this will also come back in the next presentations. So it is also interesting for the farmer itself to have a better or an improved production of your farm. So it's not only as a mitigation of global warming. And within ILVO, we developed a soil passport, and the soil passport is saying a little bit more about a certain farm, for example, because normally you have all the information available in different sources, but here within the soil passport, you can find all information related to a specific plot in one place. So it's very interesting for the farmer to find immediately all information together. And within this soil passport, they are now also developing a carbon tool. And this carbon tool, the farmer will be able to simulate how the situation related to carbon is on his farm. So the carbon accumulation on a plot and also the carbon balance. However, this information has no impact on the farm, so it will not be linked to some kind of credits or measures. It is just like the soil passport, purely informative, but of course it is a very good indicator for the potential of a certain farm. So the next speaker is Paul Pardon, and he will talk about agroforestry and carbon farming.
Yes, thank you, Riet. I will now share my screen. And if everything is working fine, then now you should be able to see my screen.
Yes.
Okay, perfect. Yes, so I am Paul Pardon. I'm a researcher at ILVO. I'm looking into topics on agroecology in general and agroforestry in specific. And so I will give a short introduction on agroforestry in general, and then a little bit more information on carbon sequestration in agroforestry systems. So first, a definition: agroforestry. Some people will know it or have already heard of the term, but in fact, this is the inclusion of trees and shrubs into an agricultural system with crops and or cattle. Now, there are multiple types of agroforestry, as you can see on this scheme, amongst other determined by the spatial organization of the tree component. For example, we have here in the middle the shelter belts. These are like the windbreaks that you see sometimes, or we have the more traditional systems such as orchards, where the trees are regularly spaced in the field. Now, as I said, this is not a new system, but there are many traditional types. For example, landscapes with a lot of hedges, also bocage in French, or the presence of pollarding trees in Flanders here in the right, where you can see willow trees. Also, meadow with poplar is a very traditional agroforestry system in Flanders, and orchards with cattle, often sheep. They are present all over Europe. And then there are some more modern types. On the one hand, we have the combination with arable fields, on the other hand, with the grassland. Now we see the distinction with the traditional types that in the modern agroforestry fields, trees are often planted in rows to allow for the efficient use of the modern heavy machinery, which is often quite big, like the harvesting combines. And then some other more modernized types with cattle or with poultry, for example, where trees are used to enhance the fields where the cattle are grazing, because they are, for example, a simulation of their natural habitat, or because they provide shade. Now, why would you start with agroforestry? There are quite some beneficial effects. On the one hand, you have a beneficial effect on biodiversity and the resulting natural pest control and pollination that is enhanced. On the other hand, there are some enhanced effects such as a better water balance and reduced soil erosion. Also, the soil fertility is generally higher. There's an altered microclimate, and it provides shade for the animals. And on another note, it creates a more attractive landscape, and for the farmer, it may also produce a higher diversified product range, which increases the resilience of farming. Another beneficial effect that needs a little bit more nuance, however, is the increased yield in agroforestry systems. It's the case that the land equivalent ratio in agroforestry is generally higher than in sole cropping systems. This means that if you would compare a system in which trees are grown in forests and the agricultural crops are grown on agricultural fields, then the total biomass production will be lower than if you spread out the trees that are grown in the forest over the total zone. In this way, creating an agroforestry system, then the total biomass production will be higher. And this is the case because the trees, they can reach to other soil layers, so they have access to more nutrients, and there's a more efficient organization, in fact, of the different components of the system. Nonetheless, you should take into account that you need a good design and also a good management. On the one hand, for example, when you plant the trees, it's important to take into account the direction of the tree rows. Generally, these are oriented from north to south, because then for you position, then the shade of the trees falls in the tree row for part of the time of the day, and also the distribution of light on both sides of the trees is quite similar. So that, for example, is one way in which a good design can be achieved. And also regarding the management, once you have planted the trees, it's also important to manage them well. For example, to prune them in such a way that a tree stem of high quality and high value is produced, rather than a tree with a lot of branches, which is worth only a fraction of a tree that is well pruned. Another aspect of good design is the specific choice of the crop and the tree species. Here we see, for example, the difference between a summer crop and a winter crop. As you can see, the overlap in the growing season of the crop and the presence of leaves on the tree. So the growing season of the tree is far bigger in a summer crop than in a winter crop. And this generally results in a greater reduction of crop yields when in the case of summer crops. These are some results of some research that we have done at ILVO some years ago, where we compared two situations, namely a situation where a field was partially bordered by a tree row, and then we put transects perpendicular to this tree row, and then also in a control part of the field where no trees were present, we put the same type of transects, so we could analyze the effect of the trees on the crop yield as a function of distance to the field border. The dotted line, these represent the transects perpendicular to the tree row, and the gray line, these are the transects in the control zone. And as you can see, there is a reduced crop yield as function of distance to the tree rows. The tree rows are in the origin of the axis, but there's quite a big impact of the type of crop you choose. As you can see, maize and potato, which are summer crops, there the reduction in crop yield is far bigger than in the case of winter wheat, which has a smaller overlap in growing season with trees. Now, an additional beneficial effect is the potential of agroforestry to sequester carbon. Obviously, carbon is sequestered in the woody biomass of the trees, both above ground and below ground. But additionally, because the trees, they produce litter, you have an additional input of organic matter into the soil. And in a similar way, also below ground, you have certain root turnover, and then decomposition, which also leads to increased carbon levels at deeper layers into the soil. On the same fields where we measured the crop yields, we also measured the soil organic carbon, and there too we can see that there was an effect of tree row presence with higher soil organic carbon nearby the trees, constant levels in the control zone, and as we go further away from the trees, we reached the same level as the control zone. And in total, for fields with poplar trees of about 25 years old, we reached an increase of about 5.3 ton per hectare in the upper soil layer of 0 to 23 centimeter. Now, probably also in deeper soil layers, some increase will be present. But if we look, for example, at research from France, then we can see that primarily in the upper soil layer, these are the soil layers, there is an increase in the agroforestry system, here represented by the black bar, which is compared to a control situation and also a situation in an agroforestry field, but further away from the tree rows. So the main increase happens in the topsoil. This is an arable field, by the way. A second point of importance is that the actual magnitude of the carbon increase is highly site specific. For example, yeah, you can see that there's quite a big effect from the specific site. This is again research from France, where 6 agroforestry fields were measured. And each time the right column is the control situation and the left one is the agroforestry situation. And you can see that there's a difference according to the sites, which also have different age. So there's an age effect, but even at the same ages, 18 years here, you can see, for example, that the green part of the graph, which represents the above ground biomass, is far bigger on this side than on this side, which has the same age. So this indicates that there's an effect of the tree species you choose, but also of the growing conditions on the site itself. Now, to remediate this problem, several tools are currently being developed to estimate the carbon content in agroforestry system. And at ILVO, in cooperation with University of Ghent and Soil Service of Belgium, we are also developing a carbon sequestration simulation tool, where we are dividing actually the agroforestry system in its different parts. For example, the first part that is modeled is the leaf fall of the trees. Secondly, this leaf fall is incorporated in a ROT-C model, which gives then the increase in soil organic carbon. And then finally, we add the amount of biomass that is produced by the trees to estimate the total carbon sequestration potential of a specific field. Now, obviously, we're still in the developing phase, and for the moment, validation measurements are being carried out. For example, when looking at biomass of the woody component, there's quite a difference between the current growing curves that exist, which are primarily based on forest conditions, versus in agroforestry fields, where trees are generally smaller because there's less competition for light, but they have a higher diameter. So there's quite some difference with the existing models for forestry. Just to say that it takes a bit of time to develop these calculation models. Now, as I said, the actual carbon sequestration potential is highly site-specific, but just to give some rules of thumb, now these are for Flemish conditions, so again, you have to take into account the soil type we have here and the climate, but you could say that below ground, depending on the type of system, being a hetero or an agroforestry field, we have about 0.2 ton carbon per hectare per year that is being sequestered, or per kilometer in case of heteros. And regarding the above ground carbon sequestration, the estimates vary between 0.6 up to 4.3 ton being sequestered either by kilometer per year or by hectare per year. Another point of importance is that when agroforestry is used to sequester carbon, this should be within the framework of a long-term strategy. In some recent research, the effects of hetero presence on carbon sequestration was studied. This was done using 3 types of systems. On the one hand, actual hedgerows, on the other hand, grass strips, and then a third system, ghost hedgerows. These are grass strips where there used to be a hedgerow. And if we look at the soil organic carbon near the hedgerows, then we see that there is an increase as function of distance. As we go closer to the hedgerows, the carbon gets higher. In the grass strips, there's just a constant level, but also in the ghost hedgerows, we see that the carbon has been reduced again to the level of the grass strips, which is also shown in this figure with higher values in the hedgerows, in the actual hedgerows, and actually similar lower values in the grass strips or the ghost hedgerows. So when trees are planted, it should actually be for the long run. Now, some conclusions. So agroforestry generally associated with several beneficial side effects. However, good design and management is key. One of these beneficial effects is the potential for carbon sequestration. But again, this is highly site specific, and there is need for a long-term strategy and not quick removal once they have been planted again. Just some sites where you can find some more information, because the time, of course, is limited to cover such a broad topic. But these are some organizations or projects that have also focused on agroforestry in general and on carbon sequestration. So you can have a look on these websites. So then I thank you for your attention, and I suppose there's room for questions at the end of the presentations.
Thank you, Paul, for the presentation. The next speaker is Olivia Barrantes from Unisar, and she will talk about holistic management.
Yes, thank you. I hope my screen is visible.
Yes, it's in presentation mode.
Thank you. Thank you. Well, my name is Olivia Barrantes. Good evening, everyone. I work in grasslands in the Faculty of Veterinary Sciences, in general in rangelands, and in the role of these grasslands in the general sustainability of ruminant systems. Sorry, I can't see my screen now. Don't know why.
We can still see your presentation.
Yes, but I can't see it.
You see the panelists, I think, or
yes. Well, I can see now.
Okay,
now.
yes.
Okay. Well, first I will comment on holistic management key elements. Then some of the tested effects on livestock production systems and environment questions. Then I will comment some questions on controversies, disagreements between several authors, and some final remarks. Well, the holistic management is above all a tool for a decision-making framework for the decisions on a farm scale. It is a highly flexible tool which combines goal setting with monitoring, continuous monitoring of the farm, and adaptive management of the resources of the farm, water, livestock, pastures, and so on. Also, it has into account the relationships between social, people, the farmer and his family and the providers and so on, the resources, and the economic output, the financial output of the farm. Holistic management is based on rotational grazing, but with specific characteristics which differ from conventional rotational grazing, such as high density of livestock with high stocking rates, but with short duration, and they give very importance to the recovery of the grasslands, long recovery time. Holistic management was developed by Alan Savory in Africa. It was inspired on rational voicing system in French in the 50s, and on the observation of the behavior of large white herds in Africa, very intense yet brief grazing pressure. As we know, not only stocking rates is important in determining the livestock production and the characteristics of the pastures, but also grazing management is still under debate. The key elements of the holistic management are, among others, recycling soil's nutrients. It needs a large number of paddocks. It needs as well more fencing, for instance, electrical fencing, less or null chemical fertilizers, give attention to wild and domestic biodiversity, and as I said before, monitoring pastures in a feedback loop. Also, will come later, soil health is a key of the system of this practice. Well, holistic management is more frequent in North America, and it is more scattered in this system in other regions. As far as I know, in Spanish, more beef livestock farmers are interested and sheep as well in these systems. In the ESAs, for instance, in the west and southwest of Spain, and in my region as well, in Aragon. Well, this is a meta-analysis by these authors, and well, before in Web of Science there are many papers in America, but then well, the interest has been spread in all regions. It has to be said that together with holistic management grazing practices terms, they are other terms and other practices which have all of them in common. The regenerative approach, also a systemic view, an holistic view of the system, and they all focus on improving management, the spatial and temporal aspects of grazing. So in general, well, I'm speaking about holistic management, but it has to be taken into account that there are other terms are set of practices very closely related to holistic management. All these practices are considered as regenerative. Why? Because they focus very much on the soil properties, the feeding the soil, and having soil health and the properties in the center of well, the three the three pillars of sustainability. To fit the complex ecosystem of the soil with all of the components, nematodes, bacteria, fungi, etc., is very important in this approach. Well, it's really holistic management and related practices is tested. Is it checked that it produces more plant production and livestock production, environmental benefits, and so on? Well, many authors have found better energy use, better farm health, plant composition, higher biomass, forage biomass, decrease of invasive plants, decrease more conservation of soil, decreasing bare ground, increase soil carbon stock, soil quality, and so on. For instance, those authors, but the results have been really very variable. And other authors, like those ones, have found no effects or even negative effects of holistic management and other practices. Those various results are depending on type of climate, soil, vegetation, and especially if the experiments are controlled in experimental farms or are done in real conditions of commercial farms. Also, combinations of management of several different. This complicates the review, the systematic review of the results of those practices. Focusing more on carbon stocks. Well, I'll give only some examples of those authors who have found positive effects of these practices on carbon sequestration, increase of organic matter, soil humus, and carbon sequestration. But other authors, as you can see, have found minimal effects or no clear evidence on carbon sequestration. Breya and others authors concluded that really the response of soil organic carbon stocks are inconsistent with negative, positive, or neutral responses. But other authors hypothesized that longer time should be needed to find significant differences. Other authors have found that the results may not apply to other pasture systems and environments, and other authors have suggested as well that integrative work with environmental, experimental, and so on should be used. What is generally acknowledged, as my colleagues have commented before, is that grasslands and rangelands soils are able to store carbon and hence to mitigate to a certain, at least to a certain degree, the emissions of greenhouse gas emissions in a really very complex manner, which depends on land use, if it is arable or it is grasslands. I think that Reed has previously presented this also this figure. So changing land use will provide losses or stocks in the soil. Land management, including grazing system and grassland systems, climate and soil type. Well, I will finish with some final remarks. There is, as I have said, that there is enough evidence of relevant carbon sequestration potential and real in grassland and rangelands. The value, the high value of holistic management and other regenerative approaches is not contested. It is acknowledged. Many factors and very complex research provides very high variable results on the effects on environment and carbon sequestration and other indicators. To my opinion, studies in real farms, in real conditions, should be done together with experimental farms, with long time and different spatial complexity scales. It should be addressed through diverse. It should be tested through diverse conditions of soil, climate, geographic regions, and different disciplines should be integrated, combining grasslands, environmental, social, economic, and soil science. To finish my speech, only to remind that beef livestock systems, particularly when linked to the land, when linked to grasslands and rangelands, are more than food, are multifunctional. They are a landscape. They are also, they have the capacity of storing and capturing carbon, particularly in Mediterranean countries. They can control the risk of wildfires, which is very important in our countries, Mediterranean countries. Traditional knowledge and innovation knowledge as well, animal welfare, and definitely in general ruminant systems are part of the solution for a more sustainable food systems. That's all for my part. Thank you very much.
Thank you, Olivia, for your presentation. The next speaker now is Hélène Chambaud from IDEL, and she will talk about two different tools, the Cap d'Azur tool and the Car Soleil, and how carbon is included in these tools.
All right. Do you understand? Do you hear me? And do you
Yes.
see my screen?
Yes.
Yeah. All right. Hello, everybody. So I am Hélène Chambaud from Institut de l'Élevage, France. I'm a colleague of Jocelyn Endurant. He already talks you about Cap d'Azur, and I will just make the link between this tool and a new development, which is a Car Soleil tool, which is a module developed to account for sequestration in beef and dairy French farms. So I make the presentation, but we worked in the study with lots of colleagues from IDEL and also from INRAE, which is Research French Center. And so I am pleased to show you some slides. So just first thing is when people want to make mitigation option in beef or cattle farm, they can be tempted to increase productivity on herd. That means higher daily gain or shortened calving age, so that they will decrease the methane by unit of products. So as you can see here, for French farms, methane emissions are more than 50% of greenhouse gas emission. So that's one point, but people mustn't forget that when you increase herd productivity, sometimes it leads to conversion from grassland to fodder crops, especially maize or grain crops, with more concentrate in the ration. And it can also be good because there is less need of space for the herd, but at the same time there is more cropping systems, and it can lead to decreased carbon in soil, organic carbon losses. So as you can see here, it's west of France, it's Brittany, and this is the red zone where we can see that there is decrease of grassland in agriculture area. So that can be a problem for carbon. And so for our French beef cattle in France, so it's just a small focus at carbon stocks in France. So the more red it is, the higher the stocks is. So you see in green points at the circular cow distribution. So you can see that the circular cow distribution are over the high carbon stocks, higher carbon stocks in France. And that's mainly due to the fact that there is lots of permanent grassland in that region. As you can see, it's a very pink zone. And on average, for permanent grassland, we are about 85 tons of carbon per hectare for the top soil from 0 to 30 centimeters. When in arable lands, we are only to about 51 tons of carbon per hectare. So actually in France, we have 44% of agricultural area which is in grassland, which is a good thing because there is higher stocks in carbon in this grass, so that's good for agriculture. But we know also that there is an evolution of soil organic carbon, and this evolution is very slow. So it is good to have a tool to show to the farmers how the management will influence these carbon stocks in the soil for a long-term perspective. So as you can see here, when we make some greenhouse gases emission advice in farms, we talk with Cap d'Azur from emission in yellow here, but also on sequestration. And until now, what we do to do so, we just take profit values to talk about this quickly. So as you can see, for hedges, there is a certain value of carbon stocks per hectare per metre linear of hedges. For grassland, it is another value. It depends of the productivity of the grassland. If you are a good productive temporary grass or permanent grass, it's higher value than if you are in pastoral area in mountains with less productive grassland. And when this grass is in rotation with crops, the year that they are in crops, we will lose carbon. This quantity is higher if we are in grass and crops less than if we are in crops and crops rotation. All right, so and we can improve the situation by sowing intercrops, which will improve the situation. So that's the way we used to talk to farms, but the advisor told us, well, it's a good thing to talk about this, but we are a bit frustrating because when we want to talk a bit more about the management of the grassland, for example, or the crops, we can't do it really with Cap d'Azur tool. So we need something to do it quickly with farmers, and that's why we wanted to improve it. And at the same time here, you can see we have had a large study in France where every zone of the France were described in very small area, and the research model were run on each pixel, and it is shown that for example, if we take the permanent grassland, you can see that the value of carbon storage can be very high, higher than 50 kilograms of carbon per year, and that's a blue point, but it can also be a loss of carbon, which can be also very high on this grassland. So on average, we are about 200 kilograms, which are captured by the grassland for long term in a 30 years perspective approach. But as you can see, there are high variation between and within the region, so we can't stay longer with forfeit value in our diagnosis. So we work in collaboration with the 4 units of INRAE and IDEL to create a transfer tool for farms and advisors, and that's the project Terre Soleil, which is actually run and will be finished by the middle of this year. So in this project, we will provide a meta model to predict carbon evolution on fields and can be used at the farm level with crops and grass. So it is based on the previous studies that I show you with this Perrin et al., which made all this calculation for France scale. And that project was funded by ADEME and the Profession of Beef and Dairy Cattle in France, Interbev. So how do we work? So first, we came back to the old simulations that were done by INRAE, and you see that each pixel is a unit of meteorological data and characters also as soil database. And it took the main management that was statistically known in each region, and they make calculation with sticks for crops and with passive model for permanent grassland. And so there was more than this number of simulation, which is very high. So translate it, it will be easier. So we took this base of data and we make a statistical approach. So it is random forest approach. And with this, we make trees of regression if you want. And so that's possible now to come from few data, which are easily possible to fill in farms and to use them to predict soil organism changes in our farm. So it is something more simplified, much more simplified than the initial model of sticks and passive. And so there is the prediction is good because we are only 8% deviation, standard deviation from the initial prediction, and more than 88% of the variability were explained. So we were happy, and so we tested it with farmers. So how does it work? So it estimates the average yearly soil organic carbon change in fields. So it's only for the top soils, 0 to 30 centimeters, and it will predict the variation under a given management in the soil and climate conditions. So if you want to run it, first you will have to, step 1, check the soil and climate context. Secondly, you fill in the practice, and then you discuss with the farmers of new management if you see that there are something where we are losing carbon, and then you can test it and run it again to see if the improved management will really improve the situation. So here is the different data that you will have to gather on your farm. So you see here it's a shiny application. So I will select the pixel where my farm is, so I can be more precise. And then by doing so, I will have screen, and I can correct the rainfall and mineral temperature in my zone. Here I have more precise data. Also, I will have a default value for the soil characteristic, but I can correct them. So if I want, I will ask to the farmer which is the thickness of the soil. And if he has got soil analysis, I can correct coarse fraction, soil texture, which is sand and clay content, pH and calcium content. and also organic matter content of this field. So I can change this to have more good prediction. It's very important to do so if you have data on your farm. So then what I do with the farmer is I will gather field together to have some typical management on typical soil of the farm. So what I would do if it's on permanent grassland, I would gather together the fields that are mainly grazed or mainly cut, or those that are both cut and grazed, for example. For grass and crop rotation together, I will gather them depending on the grass duration and crops duration, respectively. And for the crop rotation, I will look at the fertilization level type, if it's manual or mineral fertilizer, for example, if there are lots of cover crop implementation or not, and if the plots are irrigated or not. So that's the beginning. And when I have done so, I will say, well, maybe in that farm I have 5 typical situations on that type of soil that I want to test. So I will make a simulation for each type, and then I will talk with the farmer to gather the management of this type of field. So for the years with grass, if for instance I'm in crop and grass layer rotation, I will ask the farmer how many times he gets on this field to cut, to harvest, and what is the average annual yield and dry matter per hectare. If it is a grass field, I need to know the accumulation of grazing day per year. That means how many often are the animal coming in the field, what is the stocking rates, and for how long do they stay in this field. So I accumulate this over a year. I need also information about manure application. What type is it? Is it slurry or manure, solid manure, and which quantity does are applied, and also mineral fertilization. And for the year with crops, I will need, if I am in crops layer rotation, the number of year in crops that exceed with number of grass year, the types of crops I have, and the average harvested yield I've got, the fertilization level in mineral and manure, and if he sow a cover crop, how often does he sow it, and also if the field is irrigated, yes or not. So that was an example. It's very small, but here you can see I will correct the natural condition for temperature and rainfall. Here I will correct for the field if I've got analysis on that field on texture and so on. And here I will fill it the practice. So sorry, it's very small and it's French, so I can imagine you can't read. But the result would be Carsolel will estimate the carbon stock evolution for that management and for that fields, I mean, with that soil condition and that climate condition. So it gives me the average value, which is the average linear over a 30 years perspective. And then I can export this result on my Excel file, for example, and do another simulation. So the farmer can understand very easily that if the value is positive, that means that the organic matter is increasing in its field and he's happy with it. The soil carbon is getting higher. But if there is a negative value, that means that the actual carbon stock is not being maintained. And under these practices, and we can try to find a solution to have a better management to improve that. Yeah, so I will discuss with the farmer on different options. We can talk about how does it spread manure, what type of manure, if you can change it for improve the field repetition of the farm. We can discuss the grass management. Is it possible to increase, for example, grazing days, because we know that it increase the carbon sequestration, or we can talk about the species in this grass to have better yield linked to a better resilience to climate, for example. And we can talk about the fertilization with legume fixation or mineral N, for example. We can have proposition about crop slab rotation to increase the yields in grass land, because we know it will be better for carbon sequestration, and so on. You can talk about lots of things about crops, irrigation, how to have better intercrop, and so on. So, as a conclusion for the farmer, we tested it. They were really happy, because then they say we can have a global view of what is happening on the farm, not only on crops, but also on grassland. So it's a good thing. So they are interesting by result, because climate is also challenging. I would say they're organic capital soil, so they have to preserve it for the future. And so we will deliver the results of this project by mid 2002. Here is it.
Thank you, Elaine, for the presentation. Just a small reminder to everyone, if you have questions, you can add your question in the chat box. Normally you can find this on the right of your screen. And then at the end of the webinar, we will come back to the questions and give you an answer. The last presentation will be given by Ennio Fuck from ILVO, and he will talk about reward schemes for carbon sequestration.
Great. Hi, everyone. Thank you for sticking around. I'm looking forward to the questions when we finish, and I'll get right going. I'm going to be talking about reward schemes for carbon sequestration, as mentioned. There will be some information that I will skip because it might have been said already. But first of all, I'm presenting some insights and results from the Life Carbon Counts research project, which I'm involved in. It consists of performing a system analysis and roadmap for the implementation of agricultural carbon farming in Flanders using a multi-actor approach, so really engaging everyone involved. We're going to be translating this and adding alongside it the foundation of a long-term action platform, a carbon action platform. Why? Because it's essential to get everyone involved and to really have good collaboration between private and public sectors. Alongside it, there is also cooperation with the Department of Agriculture and Fisheries to establish a geodata platform. It's mentioned already, soil passport, for example, will be a vital component of this, and several calculation models for carbon, such as the tool that we just saw, for example, could be built onto soil passport and really enable us to give everyone the information that they need to have, for example, carbon farming schemes. Specifically, there will be a design, implementation, and pilot phase for agroforestry, small woody landscape elements, and carbon sequestration in arable mineral soils. All right, so we have already seen what carbon farming is, but let's look at it from a business model side. So we have, just let me, 1 second. This is obscuring my view. There we go. So we're looking at carbon sequestration, but very importantly, also reducing the release of carbon to the atmosphere. It's not only CO2, but CO2 equivalents, so other emissions can be translated. Some benefits, we've already seen them, but of course, we will increase the carbon sink capacity of agricultural soils and thereby increasing removals. Very important, of course, is just having that additional income for land managers. So what is a carbon farming scheme all about? Well, it's about reducing obstacles and increasing incentives. So this is absolutely vital. And I wanted to point out that incentives could also be informal, such as reduced rates for leasing plots of land. It doesn't always have to be direct payments, but of course that is the main gist of it. Co-benefits and climate adaptation are also essential. So the most pronounced ones are increased biodiversity and, well, nature, ecosystem functionality, let's say, and increased climate resilience of the farmland. All right, let's give some examples. We have what's all included is afforestation, reforestation, use of several sustainable and carbon sequestration increasing practices, such as conservation tillage, catch crops, cover crops, peatlands and wetlands, restoration and rewetting mainly, the land use changes, let's say, from croplands to things like permanent grasslands, agroforestry and all other forms of mixed farming, and blue carbon farming. Of course, I work for ILVO, so we'll be focusing on agricultural carbon farming. Which ones are those? Well, we're going to be focusing on these ones. So the several types of croplands practices and landscape features, grasslands, agroforestry. In peatlands, you could take it into account in the form of polludiculture, which is actually a type of agriculture on on wetlands mainly, but it's really underdeveloped, so we won't be going into detail today. But it is very interesting, especially in some areas of Europe. Very important that a lot of carbon farming, we had an argument before the other way around that sometimes it's more intuitive to go to the emission reductions. So for example, the enteric emissions of cattle and to look there. But at the other side, in practice, we're seeing that a lot of organizations focus on these carbon removals because it seems to them more intuitive in carbon farming. It's very important to note that from a climate mitigation perspective, these two can be valorized in an equivalent manner. So a removal or a reduction or an avoided emissions are all very important categories to take into account and to valorize. Okay. Some brief policy context, because I'm talking about a voluntary carbon market. It's important to know that on the other side of the fence, there is a compliance market, which is within the ETS or emissions trading scheme. This is a legal requirement for certain sectors, specifically energy intensive sectors and commercial aviations within the EU or the European Economic area, let's say. And on the upside of the emissions not covered by the ETS are then covered by the ESR or the effort sharing regulation. This includes transport and energy used for households, but very importantly also agriculture. So there are targets that as a government, the government is concerned about reaching, of course, and some initiative needs to be taken, and a lot of initiative, in fact. And then lastly, we have the LULUCF or AFOLU sector. Why is this important? Well, this is the land use change and forestry sector, which will have a significant transformation at some point to include agriculture. And then we have a lot of target dates that are put out now. These are ambitions, but it's important to strive to reach them. And it's 2025, no debit rule. What that means is that in agriculture, we want to not lose any of the current carbon stocks in general across Europe. By 2026 and 2030, we want to increase these carbon sinks and activate them to have a negative 310 megaton CO2 equivalent storage or carbon removal, let's say. By 2035, there's the ambition to have AFOLU, so agriculture and forestry and other land use, to have a climate neutrality. What that means is that the sources, the carbon sources and the carbon sinks should be in balance. Why am I here? My research actually stems from the Flemish Energy and Climate Plan, amongst other things, of course, which states that we should establish a Flemish voluntary carbon market to help reach our national targets for agriculture. So within this LULUCF, AFOLU, and effort sharing regulation. All right, we got that done. I'm going to show you the current state of affairs in Flanders and make some links to international systems as well. What do we have in the market? We have supply and demand. What's the supply? Well, it's farmers and their projects, their lands, their grassland, their cropland, their anything really that they manage. And the demand side could be a number of things. Could be businesses, could be the government itself or local governments like counties or other farmers. But it's very important, it's a voluntary market. So you can't buy any certificates or you can't buy carbon sequestration to account for legal requirements such as ETS. What you can do is do a contribution or do some your part in a compensation towards a pathway of net zero. So climate neutrality within some bounds. The most simple way this can happen is just direct interaction, just supply and demand. They make arrangements. In Flanders, you have a couple of these projects which are listed there. And you just agree, like, I'm going to be doing this and it's going to be sequestering more carbon because you point to some literature, for example, and you're going to pay me X amount of money. Okay, we agree. Let's shake on it. There you go. Usually, this kind of arrangements are practice-based. There's no too little measurements or modeling. There's a holistic approach. So the principles of regenerative agriculture are usually followed or respected, and no formal certificates are generated. So it's usually just you do this and you maintain it for, let's say, 5 years. I'll give you X amount of money. Of course, there will still be some validation and verification, like did everything occur according to plan within those 5 years? Did you stop doing the practice for some reason? And then this might imply no payment. But yeah, we hope, of course, that these projects are sound, and the ones here in Flanders usually are. There you go. So a more complicated situation occurs when there is no direct interaction. And this is actually evolving more and more towards a more complicated market, but also a more mature market, let's say. And that's when project developers and carbon brokers come onto the scene, which is the case right now in Flanders and in many other countries. What do they do? Well, they set up new projects, they agree on some methodology, they make agreements on very important criteria, such as additionality, permanence. They make agreements between the supply and demand side. They have oftentimes a portfolio of projects which they use to balance risk between several projects. They can sometimes make tools or adapt open source tools, and they train advisors, they go advise farmers on how to use these tools and all kinds of things. In Flanders, we have a couple of examples shown on the screen there. And as said, they interact between supply and demand side. So they set up a project, for example, and this leads to an increased carbon in soil and biomass of the supply side within a project. That's great. And using that methodology, they can say to the demand side, well, you can trust us because we did this and this. There's some transparency there. And the demand side says, okay, well, I'll buy X amount. It's usually still practice-based in Flanders. There are some hybrid systems going in, for example, France under label Bas Carbon, or the Netherlands under Stichting Nationale Koolstofmarkt. There is mostly use of modeling, also soil samples, but they're oftentimes used for the calibration of the models. And usually there are formal carbon certificates. So this project generated X amounts of ton CO2 equivalent of carbon sequestration. Again, after some validation and verification, you can get payment. We're almost there. Because the last part of the puzzle is a very important strategic one, and that is getting that scientific consensus and coordinating this entire thing. We have large differences. To give you some perspective, in Flanders, no real decisions have been made yet. So there's a huge amount of freedom, which can also, it can be a very good thing. The market is free to innovate, and the market is free to make a lot of pioneering decisions. On the downside, there is nothing stopping unfavorable situations. If some organization arranges an agreement to bury all type of a food crop in the soil for carbon sequestration, makes a payment based on that. There is no real regulation stopping that, but obviously it has ethical complications. In France, for example, you have under Label Bas Carbone, which is of course not the only carbon farming scheme, but a very large one, a highly centralized system, which the government takes a lot of these decisions and says like, okay, we're going to be using these standard values, we're going to be using this methodology, your methodology is good, yours needs some work. In the Netherlands, we have a system where the government took a lot of action at the beginning, setting up a platform, getting scientists, private and midfield, what's the word, civil society organization together. And then they took a step back. So now it's more of a self-governing situation. So this last piece of the puzzle, what does it do? Well, actually, it needs to have an increased accuracy on the statement how much tons of CO2 equivalent is actually removed from the atmosphere. So just how much are we doing here? And this could be by having better tools, better models, having better agreements on what type of practices are additional and providing that scientific clarity on that front. Okay, I hope you learned a lot. This is my final slide. That was the current state of affairs in Flanders. And now, how are we going to get from there towards a widespread implementation and success of this voluntary carbon market? As I said, we want to reduce obstacles and increase incentives. But also, we want to find common ground. So we recognize that there are a lot of priorities, and a farmer, for example, would like some flexibility in their farms. They want to maximize their income stream. So if they participate in a carbon farming scheme, they want to get a good enough reward so that it's feasible. They don't want a complete disruption of their strategy and all of those things. The private market wants stuff like having large-scale farms, so it's easy to go and check everything, to have to apply your methodology. And the government, for example, might prioritize accurate measurements so that they can have this contribution to the national targets. And we have to find common grounds and have an equal playing field for everyone. This is part of the Carbon Action Platform that I will highlight in the end. Another thing is we're talking about local projects here because there's when doing voluntary carbon markets actions, there's a lot of price competition between the global south and local projects such as here in Flanders, because it's simply more expensive a lot of time to have a same amount of carbon sequestration here than it is doing some practices in the global south, which might be not related to agriculture at all, but still they're in the same market. So it's important to recognize that and to valorize the value of local, because there's a lot of image effects and co-benefits that go into that. What do we want? Because it's a voluntary market, we need trust or the entire thing collapses. We need trust and quality so that 1 ton of carbon sequestered from one project can be equated to another project, or at least it's similar. Nobody wants double funding, so there's a lot of these very important criteria, which I will not go into depth on, but one is additionality. What does that mean? Well, I don't want to fund anything that is going to happen anyway. And companies, private companies, do not want to do this. Farmers don't want this, and the government doesn't want this at all. So let's avoid that, and we need to have agreements on how to avoid that. Permanence. In the ideal scenario, you keep carbon in the soil for 100,000 years, which is, of course, not going to happen. So you need a realistic timeline for your project. A farmer might say no to having a certain management practice for 10 years, but he might say yes for 5 years. So we need to have an agreement there and to keep it flexible. And then there's a lot of different things like risk management. What if the field floods? What if there's a wildfire? What if there's abuse in the system? How can we quantify uncertainties? As we have seen before today, there's a lot of spatial heterogeneity. I'm sorry if I butchered that. There's a lot of different effects of certain practices in different areas of your region. So we wanted to keep things cost effective, but also this causes a large amount of uncertainty. So if you have a methodology that encompasses an entire region, how do you account for all of these different soil types or different combinations of practices? We need to have some agreements and some conversations on that. And then also innovative financing methods. Not every practice has the same cost. Some costs a lot in advance, and some is just a nice annual cost that can be divided between the project duration. We have to take this into account and get something on the scale that is required for the farmer to participate. All right, finally, we have to develop reliable methods. So we've already seen some explanation of tools. We've seen some holistic management and a lot of literature that sometimes conflicts. So the way we have to get there is by closely collaborating between scientists, policymakers, the private markets, and the farmers. Everyone has to work together, be open source as much as possible. So tools, calculation methods, and models developed, we can get there towards a highly functioning voluntary carbon market if we put our brains and our results together. We have to reach some type of scientific consensus on what values and methods we'll use so that we get these comparable results in carbon certificates generated by a certain practice. And then, of course, we can't forget education and opportunities to train and employ advisors, auditors, and carbon credit rating agencies. That last one is for when the market is pretty mature, but it's another layer to ensure projects all have a high quality. I'm going to be finishing now and just saying that the Carbon Counts research is doing three main things that might be of interest to you. And that is this system analysis, where we study regional and international carbon farming schemes, compare them and apply them to our regional context. We're going to be translating that into a roadmap, which is basically a list of priorities, how to get where we want to get in Flanders. And then alongside it, we want to structure this collaboration that I mentioned before into a carbon action platform to get everyone together and working towards that future. Thank you for your attention. You can screenshot this slide if you want to contact us. We're very happy to receive any and all questions and to talk to you about your aspirations for carbon farming and carbon farming schemes. Thank you.
Thank you, Ennio, for the presentation. I have a question from Luis Thiago for Paul and Helene. What methodologies and techniques like remote drone manual have you used to collect the soil data to establish these analysis parameters? Can you provide references? So maybe Paul, you can go first.
Yeah, for the soil sampling, these are just no remote sensing was used. Now for the model, the carrot model, in the future, the idea is to actually start using remote sensing tools, but mainly then to quantify the woody components, the size and the presence of woody components. And for the for example, the initial soil carbon content, which is of importance in the model, farmer analysis conducted by the farmer will be used, or farmer data gathered by the government, also based on soil samples.
Helene, you're muted.
Sorry. So in Castle tool, when you select a zone, then there is pixel in the back, and this pixel come from INRAE database. So it's RMQS, which we call Réseau de Surveillance des Sols in France. So it's measurements that are done on a grid for all the French. So you can take this data for grassland or for crops, and that's what we use. So it's measurements. And if you are on a farm and if you have a real analysis, so it's much better to take it because it's very important for the calculation. And it's difficult to predict what is the level of organic matter in your field if you haven't done any analysis. So it will be much better if you do it. But I'm not sure I understand very well the question. I hope it's okay for the answer.
I think the answer will be okay, and otherwise they can ask the question more specific. Then I will turn to Mimi. Are there other questions?
We haven't got any questions in at the moment, but Louise has just said thank you both. So I think you did answer his question perfectly there. If anyone does have any further questions, please do pop them in the questions box because we do have a bit of time now to answer some questions.
Otherwise, I had a brief question for Helene. Unless, of course, a question from the audience take priority. The tool that you developed, congratulations, by the way. I was wondering if you have this perspective of linking it to some form of carbon farming scheme, like because you have a tool now to predict the effective management practices, you could link it, I suppose, to a rewarding of a positive carbon sequestration trend somehow. Is this, have you thought about this?
Yes, we have talked about it. The first mission was to give something to the farmer to reflect about what is good for his soil or not. So that's the first stuff. So we will have a link at the end of the project, and any farmers in France can get there and make some calculation for his own farm, so he can see if it's good trajectory or not. So that's one. But there you will just do one simulation for one field, and then you have to do it again and so on. So for people with Capdozer tool, in next year we are thinking about to make link between Capdozer and Carsolel, but not this year. And if we want to make it for labelization, then for carbon credit, so I have first to publish it. So we will publish the model in next June in HDF seminar, congrès, yes, in France. So that's the first condition, and then I have to go with ministry and so on to present it and this methodology to be accepted. But I think there will be no problem because it is on sticks, which is on AMG model, which is already good for labeling crops. So that for crops, yep. and grassland. And the other one is one from French research, so that wouldn't be a problem, but it needs time.
Great.
to be
yeah, exciting.
Yeah.
Well done. I wish you the best of luck.
We have a question that's just come in from Raoul that says, first of all, congratulations for the webinar. Very interesting presentation, so thank you all. And there is a question here for Olivia. Are there any project ongoing studies that these grazing systems on the Iberian conditions? I'm just going to forward you the question as well there.
Yes, well, if I have well understood your question about projects in Iberia.
Yes, I believe so.
Yes, there are a project which is called Go Dehesa, for instance, in the dehesas, which are agro-silvopastoral systems, and they are they are searching about the differences between, well, in these systems, there are conventional rotational systems, sheep or beef cattle rotational systems between paddocks, but they are comparing as well the conventional rotational with holistic management. So they need more paddocks, smaller and more number of paddocks, and they and also electrical fences, and they are searching carbon sequestration and in general soil health, soil properties, and as well the number of livestock units the same paddocks can feed. Yes, the system can feed, and they are having interesting results. Yes.
Great, thank you, Olivia. We've had another question as well for Enyo. Are there carbon farming certification projects that work already in Europe and Spain?
Well, there are several projects in Spain going that I know, but I think they mostly focus on forestry. And I haven't been looking closely at them because we've mainly studied the systems in France, Netherlands, UK, and now starting on Ireland. There is going to be an inventory in the Road for Schemes project, which will have a large database of all ongoing carbon farming schemes. So I'd recommend keeping an eye on that. And then in this difference between Spain and Europe, let's say, it's very important to think that, well, to realize that most carbon farming schemes going on right now are confined to a region or a country. Why? Because if you want to trade carbon credits, for example, between national borders, there's a lot of Paris Climate Accord things going on, and you would have to resort to international standards, which can be very expensive. So yeah, I just wanted to point that out because you mentioned Europe and Spain. And it's a very distinct trend, let's say, that these confinements to regions or countries. I hope that answered your question.
I think if no further questions are coming in, maybe we can end the webinar. You can always contact us, of course, if you have later on questions. You can contact the panelists, or you can contact Mimi, and she will make sure your question will come to the correct person. I would like to thank the panelists for the interesting presentations, and then also I would like to thank the attendants for following this webinar.
Bye-bye.